All right, today we'll check out some, let's just close OneNote and reopen it because it doesn't like to act so nice. All right, today we're going to check out some increasing and decreasing functions. Now this is actually easier than what we've been doing the last month, I think. Okay, should be able to get this down fairly easily. Okay, because the first derivative is the what? Slope. So if the slope is positive, what do we got? Increasing function. If the slope is negative, we have a decreasing function. If the slope is 0, we have a yeah. Where's the slope 0 there? Right there. You have extremas. Ooh, I like the word. Yeah. So you have maxes and mins. So when the slope is 0, you have maxes and mins. So when where your critical numbers occur, what's going on? Maxes and mins, right? So when we were working with critical numbers last time, we were basically finding maxes and mins and then asymptotes, because that's where things can happen. Oh, let's look at this. It says, over which intervals is h increasing? So, since this is calculus, we're going to find the first derivative. The first derivative of h of x is 4x cubed minus 6x squared. Okay, set the first derivative equal to 0. 4x cubed minus 6x squared. Factor out what? 2x squared, and we get 2x minus 3. So our critical numbers are at x equals 0 and x equals 3/2. I draw a number line. Those are our two critical numbers, right? Solved. Set 2x equal to 2x minus 3 equals 0. Move the 3 over, divide by 2. Okay? So what numbers are in between 0 and 3/2? 1 is in there. So if I put a 1 into the first derivative, I get 4 minus 6. The first derivative at 1 is 4 minus 6, which is a negative 2. What is happening to that graph between 0 and 3/2? It's decreasing. It's going down like this. 3/2 is a critical number. It'll increase after that, right? Now, we also have to check on either side. Okay? So negative 1 would be on this side of 0. So let's find h of negative 1. See what's happening there. If I put in a negative 1, I get negative 4 minus 6, which is a negative 10. What's happening over here? It's still decreasing. It's decreasing the whole time. So let's take a number on this side, like 2. What's the first derivative at 2? Well, that's 8 times 4 is 32, minus 6 times 4, which is 24, which is a positive 8. So it's increasing after that. Where is it increasing? Well, it's from 3/2 to infinity. Okay, so these are your critical numbers, and you have to check numbers in between your critical numbers into your first derivative to see if it's increasing or decreasing. Can you do that? That doesn't sound too hard. Okay, compared to what we've been doing, that's not too bad. All right, let g be a function defined for all real numbers except for negative 3, because negative 3 will put 0 in the denominator. Okay, where is this decreasing? Okay, well, we have to figure out we're told that this is the first derivative, so we don't even have to find the first derivative, okay? We set the first derivative equal to 0. If we multiply both sides by x plus 3 quantity squared, what do we get? X minus 2 equals 0. So x equals 2. 2 is a critical number. What's our other critical number? X equals negative 3 is a critical number. Why is that a critical number? Because it makes an asymptote there. It's probably going to be an asymptote because it basically it's defined for all real numbers except for negative 3. So I'm assuming that it's an asymptote, not just a hole. Draw your number line. You have 2 here, negative 3 over here. What number is in between 2 and negative 3? 0 is the easiest one to work with. If you stick in a 0 here, you get a negative 2 over a positive 3, or actually a positive 9. So you get negative 2, 9. So what's happening in between here? It's decreasing. What number is to the right of 2? 3. If you put in a 3, you get 1 over 36. So it's positive, so it's increasing over here. Try a negative 4 over here. So negative 4 minus 2 is negative 6 over whatever. It doesn't matter. It's a negative over a positive, which is a negative, so it's decreasing here. Okay? So which intervals is it decreasing? Well, from negative infinity up to negative 3 in union with negative 3 up to 2. Why don't I put a bracket instead of, why do I put a parenthesis instead of a bracket? A, at negative 3, we're not included. It's not a number, but why about 2? Why don't I bracket it at 2? Why do I put a parenthesis and bracket? Because at 2, what is our first derivative? 0, so it's actually horizontal. Our slope is it's not decreasing or increasing. It hits a min there, so it's not at that point. Up to that point, but not there. That's where it's decreasing. Okay? See how the number line really comes in handy here. You do the number line, you figure out what happens at each stage along the game. Okay? All right. Now we're looking at minimums and maximums. So here's where the first derivative, this is what the first derivative is. Okay? So we set the first derivative equal to 0. How many different spots is the first derivative equal to 0? 3 different spots at negative 2, negative 1, and 3. So how many points have a relative minimum it's asking? Well, again, number line time. Negative 2, negative 1, 3. All right. And these are my critical numbers. Okay. So, the easiest one to check is 0 here. If we put a 0 into the first derivative, we get 2 times 1 times negative 3, which is negative. Okay. Let's try a negative 1.5. into there. We get a positive times a negative times a negative. A positive times a negative is a positive. So it's increasing there. On the other side of negative 2, let's try a negative 3. We get a negative times a negative times a negative, which is a negative. Negative times a negative times a negative. 3 of them. You got lost. Okay, that's fine. And then 4. Positive times a positive is a. Okay, now this is what the slope is doing, Maggie Ingebretson. This is an important thing, so that's why I stopped you from doing whatever you were doing on your computer, because it was a little tougher to understand. When my slope is negative and then it becomes positive, is this a min or a max? As it's coming in, it's negative. As it's going out, it's a positive. This is a min. If it's positive coming in and negative going out, it's a max. And then this one would be a min. Okay? So if you do your sign chart on your number line, you should be able to tell if it's increasing, decreasing, and where your mins and maxes are. It's got two mins. Okay? Two relative mins. All right. This one doesn't give you the first derivative. Oh, no. It doesn't give you the first derivative. Skip it? No. What my people generally do is just, in the past, they just put it on the graphing calculator and figure it out. So, but for what value of x does g have a relative minimum? Well, if we do the first derivative of this, it is lots of chain rules going on. What I'm going to do is multiply the negative through. So I'm going to have negative x minus 1 times x minus 1 squared. So if we do chain rule here, it's negative x minus 1 times 2 times x minus 1 times 1 plus x minus 1 squared times negative 1. Okay, so if we factor out of this an x minus 1, we get negative 2x minus 2 plus, if we factored out a negative 1, or an x minus 1, and we have a negative 1 and we distribute through there, we get a negative x plus 1. So x minus 1 times negative 3x minus 1. Okay, that's our first derivative. So x minus 1 equals 0. Negative 3x minus 1 equals 0. So x equals 1. Move the 1 over, divide by 3. X equals negative 1/3. So where does it have a relative minimum? 0, 1, negative 1/3. At 0, if I put a 0 into this function right here, I get a negative times a negative, which is a positive. So my slope is going up. If I put a 2 into this function, I get a positive times a negative, which is a negative. If I put a negative 2 into this function, I get a negative times a positive, which is a negative. So it's decreasing then increasing. So the min is right here. The max is right here. So at negative 1/3. Okay. So some of these take a little more work. Okay. Something like this doesn't take as much work. What's the first derivative of this thing? If we factor out a negative 3x squared, or negative 3x, and we get x minus 2. 0 and 2 are our critical numbers. So if we try 1, put in a 1, we get negative times a negative is a positive. We put in a 4, we get a negative times a positive, which is a negative. We put in negative 2, gives me a positive times a negative, which is a negative. Where's the relative max? Well, where it's going from positive to negative, which is 2. Okay, absolute maximums. Okay, to figure out an absolute max, we also have to look at the endpoints. Okay, so we find the relative mins and maxes in between, and then we have to look at the endpoints. So let's look at this function. What's first derivative of that function? negative 6x squared plus 6x plus 36. Factor out a negative 6. Then you get x squared minus x minus 6, which is negative 6 times x minus 3 times x plus 2. So x equals 3 and negative 2 are my two critical numbers. I think the screen froze. All right. Okay. So I have to check negative 3, negative 2, 3, and 5 on this. Okay, I have to check all those numbers. So I put all of them into, well, I suppose I could put them into the original function and find the maximum value. Okay, what's the biggest value? So stick a negative 3 into here. Stick a negative 2 into here. Stick a 3 into here. Stick a 5 into there. And figure out which one gives you the biggest number. Okay, I would do that on my calculator because I don't want to try to calculate all that out in my brain for 4 of them. But then you figure out the answer. Okay, you got to figure out all 4 of them, put them in the original to find the absolute maximum. Same for the absolute minimum. Do the first derivative, 6x squared plus 6x minus 12. Factor out a 6 and you get x squared plus 1 minus 2, which is x plus 2, x minus 1, which is x equals negative 2, x equals a positive 1. And then you have to also include the endpoints, so negative 3, negative 2, 1, and 2. After you take these 4, put them each into the function, get your answers, and whichever one gives you the smallest number, that's the absolute minimum. Okay. Let's do this one. We need to find the absolute maximum of this function. The absolute maximum of this function. So to find the absolute max, we have to find the first derivative. So the first derivative of this is what rule? Quotient rule. So it's x squared times 1 over x minus the ln of x times 2x all over x to the 4th. So it's x minus 2x ln of x all over x to the 4th, which if you factor out an x on the top, it's 1 minus 2 ln of x over x to the 4th, and one of these x's and one of these x's cancel to be x to the 3rd. Okay, so that's my first derivative. I set this equals 0, solve it. So 1 minus 2 ln of x equals 0 if I multiply both sides by x cubed. So 1 equals 2 ln of x, divide by 2. Ln of x equals 1/2. And to get x alone, we e both sides. So x equals e to the 1/2. X equals e to the 1/2 power. So that's either our max or our min, e to the 1/2 power. I wonder if I did something wrong or if I hope I'm right. All right, so e to the 1/2 power, which I don't see over there. 2x ln of x, take out the x, 1 minus 2. I don't see where I made a mistake. So maybe I didn't make a mistake. All right, so e to the 1/2 So if we try 0 into this function, if we put 0 in the original function, what's the ln of 0? It doesn't exist, does it? No, it doesn't exist. So the graph, I think, comes up from here, probably. Negative squared is positive. Negative. I think it comes up from here. And then I think it would probably keep going up. I would want to look at a graph of this just to be sure. But I don't think it has a maximum value because I think it keeps going up forever.
It is at the value that we got it,
e to the half.
It just doesn't give it as an answer.
Wow. Because none of these are, yeah, that's really weird. So, interesting. Let me look at Desmos ones. Y equals parentheses ln of x over x raised to the second. Wow. So the max would be right in there. Yeah, I don't know. What happened to this? Do I have an answer key? No. All right. Well, whatever. It is strange. Yeah. Maxes, mins. I'm going to let you get going and let you figure stuff out. And